before we start the track 2, I have a question. How many of you use AI tools on a daily basis? Different tools. How many of you are using paid tools, like you are having bills at the end of the month or end of the year? Okay, so you might be the people who loves AI tools but hate the bills, right? Right? Yeah. So our first track or first session of this track 2 is all about that. We are talking about 14 times cheaper AI. You heard it right. Yeah. So the session 1 is 14 times cheaper AI, a real world LLM distillation case study on Bedrock. For the same, we are having two amazing speakers, Manu LS and Joshwin Tennyson JS. So we are having two experts, one powerful case study and a lot of value. Let's welcome them with a big round of applause.
Hello. Hi. Welcome everybody. Thanks for the introduction. Hope I'm audible. Okay. I will start with the. The heading is saying 14x. Very very curious. Everybody will know what do you mean by 14x cost saving. That will come to the last part of the session. But the problem statement is that in air cargo we typically get a lot of email inquiries, and what happens in normal manual process is that somebody has to look into their mails and understand what is there as an entity level in the booking, right? And then extract all this manually and then pass it all this into a booking page, right? So there are manual process involved in terms of understanding what is there for the requirement for pre-booking perspective and then transferring that into booking end. The reason why LLM comes into picture is in terms of automation, right? When you look at from LLM from automation perspective, LLM is able to understand the conversations that happen through the email, and it is able to extract and find out the entities as well. So the problem what we are trying to solve is essentially an entity extraction problem from a language using LLM, right? It can be done using an LLM. Any LLM will be able to do it. You only need a prompt engineering or prompt tuning from a capability perspective. The reason why we went for LLM is just from a cost perspective and efficiency perspective as well. That journey is what we are going to detail right now. So hope I have outlined the problem slightly. Okay. Joshwin will, my colleague Joshwin will talk about the rest of the parts. I will join in between. So I'm handing out to Joshwin.
Yeah, thanks, Manu. So, as Manu mentioned, in our cargo emails, we usually have huge entities that should be extracted in order to place the bookings. So, these are kind of emails that different agents from different parts of the world share in order to place email bookings. So these are kind of cargo email with cargo entity details. So currently the process is something like the agents, there will be different human agents who are translating the mails into the entire context and content, and they will be placing the booking request. So in order to reduce the efforts, what we have done is we will be using different LLMs in order to extract the context and the entities within the emails, and we will be populating those and triggering the email or booking APIs so that the bookings will be placed automatically. So this is the entire flow. So first we will start with the business problem. So the first problem is like in the emails we have huge amount of data that is coming in consistently, and the issue is like it is kind of bilingual, and there can be local codes which humans use, and also there can be local slang issues which can be a challenge which a normal LLM or a normal agents cannot understand directly. So that is one of the challenge, and there is a high amount of volume that is coming up within minutes, and we should process it in real time within very less latency. So these are the key challenges within the data, and we should extract the entities. The entities mean there can be flight numbers, the source and destinations, there can be modification requests within the emails. So these should be properly identified, and we should take action upon that. So as I mentioned, for the challenge we have, the goal is like we should automatically identify the entities. Yeah, we should automatically identify the entities, and we should get a accuracy percentage which should be around 95 to 98 percentage. Otherwise, the agent or manual effort will be again high. So, in order to achieve that kind of accuracy, we should go with a high performing LLMs or agents, which will provide us with a great accuracy. But comparing the rate of return on investment, actually we will be having a kind of profit receiving from each email extractions, compared to a manual agent. So what happens is, like, we can't spend too much of cost on top of this pricier or heavier LLMs. So that's where the challenge, and also we should have a low latency. So in order to have this tackled, what we did was we took a heavier grade LLM which performs in a higher accuracy, and we distilled, or we just extracted the performance of the higher LLM to the small lower LLMs which cost us very less. So there also we have a point. So if we are planning to host a LLM in some kind of servers or GPUs, it costs us too much. So where the AWS comes into picture. So AWS provides a serverless kind of thing where we could host the Nova models, which is from the AWS family itself. So we could host it in serverless modes. Even if it is a custom LLM, we can host the model in a serverless mode. Yeah, so moving to the next slides. So we have done numerous number of testing and also research on this end to end. So there were different steps in the entire journey. So first we thought of approaching this in a kind of normal NER, normal entity recognition, and which is a kind of classification, but we approached finally it as a kind of sequence to sequence kind of generative mode. So as you can see in the left side, the prompt one or sequence one, where we will be having the entire prompts plus the email, which gives us the context. So this is being fed to the model, and in order to receive the output which we expect like this. So this is being done with the help of the prompts. We will be tuning the prompts in order to get a kind of expected output, and the input for the prompt or the LLM is prompt plus the email context. And we will be expecting the JSON, which is a kind of generative thing. Yeah. Sorry. As I mentioned, we are following a distillation method. So maybe some people knows like LLMs have different layers, and it comes across different layers in order to give us the output once the input is fed into the LLM as a prompt. So maybe you can see this as a huge teacher LLM or a model, which is having a higher accuracy and which gives us a proper and good output, but cost us very huge. So this we have tried out with different large models like Cloud 4 models or Llama or Llama large models, and we use a student model which is of the similar family. And what we does is we will be giving inputs to the teacher model, and the output which comes out from the teacher model will be fed in different layers of student model in order to adjust the weights on each layer. So this will be done in different epochs. So different iterations will be done so that the student will learn how the teacher behaves. So that is the entire process. So we will be compressing the knowledge from teacher and we will be feeding it to the student. Yeah. So this was done in order to achieve a higher accuracy within a limited or lower cost of the student model. Yeah. Maybe, yeah. So Manu will be explaining the steps or the entire journey which we come across. Yeah.
Thanks, Joshwin. Just before I go into this slide, distillation, when you talk about distillation, there are multiple ways of doing it, right? So there is a logic-based approach, there's a probability, there's a output token-based approach, there's attention mapping mechanism. There are multiple ways in which you can distill information. There are frameworks out there in the market. So essentially, if you look at from this presentation perspective, we ultimately did it in AWS, but that's what the end point is. The reason we are talking about this journey is to understand, to give a glimpse of the complexity of the problem and how we can deal with it. So the first one we tried is logics-based mapping. So as you can see, we are basically, in this approach, we are basically comparing the output of both student and teacher. So again, just to put in purview, for the vlogs who are new to the distillation concept, we provide the same input request to both teacher and student. And what we are essentially trying to do is asking the student to learn from the teacher model, right? So there are multiple methods, as I just mentioned. So one of the method is logics comparison, which is basically comparing the output, and the error terminology generally the industry use is scale divergence. Again, I'm not going to max out the part. You can go in your own time. So, but the point is we compare the error of the outputs for both the students and the teacher, and we ask the student to retrain the model. Essentially, the neurons are forced to do the backpropagation, retune the weights, and so that both are in sync. That is essentially the crux of the matter. But the input or the trigger for that is based on the logics. This is one of the method of doing it. The point is here we need a close mapping with the teacher and student model. Let's, for example, for argument's sake, take Llama, large and small models. Makes much sense, but again, the architecturally, if it is similar, it will be slightly more easier. But that is one of the way of approaching it. So that we tried. That is one of the approaching. So I think. Yeah. Next one is a feature-based model. Here, again, if you understand the transformer model, there is a layer in between where we call the attention layer, and there is a feed-forward layer as well. What in this approach, what we are trying to do is we are doing the attention layer mapping. This is slightly more complex because the problem here is that the large argument have multiple attention layers. Like if you know the going to deeper transformer, there is every attention has a attention layer, and there are multiple attention layers. So mapping the attention layer to a small language model is a slightly complex one. You have very tight, should have very tight architectural similarity. Like one example, what we can give is, for example, Nova Pro and Nova Lite are much more very closely architecturally similar, but Llama models are not so good. So when you're trying to build this using some of the custom framework out there in the market, for example, there are multiple ways of doing it. You can build custom PyTorch framework, and there's the most famous largely used is TextBrewer, is the open source distillation framework. For every framework, if you use it, there are multiple chances in terms of mapping. The error we use here is mean square error. It's a pretty simple error terminology, but the point is about mapping and understanding nuances, how we can map it. The other complexity is, if you again look into it, large complex models have multiple layers, and you probably have to map 3 to 4 attention layers into a single map into a single layer within the SLM. So that is again slightly more complex. You need to understand in-depth architectural nuances and how to handle errors as well. So that is another way of doing distillation. The third is a token-based system. And this is slightly more easy because the other things what I talked about, the reasoning capability is slightly more drilled down or distilled. But here, if you look into it, we are just taking the output, and but we are not taking the output alone. We are taking the token level output. So that means if you again, I am going to architectural part. If you take the softmax output, there's a probability. Softmax gives us the probability distribution, right? So that level token level distribution, it's being captured here. So you go for a cost entropy kind of error term here, and you can then what you use the cost entropy as error term and ask the teacher model and student model to compare between those two. This is again, it can be done in frameworks using like TextBrewer, etc., and other custom PyTorch frameworks. If you can build it, it's possible. But I will come to the nuances later. Okay. So just to summarize, we tried a token-based system using a PyTorch custom framework. The problem was that the output JSON files, so, as Joshwin was mentioning in the initial mail, if you have noticed, right, the output files are JSON files because we are looking at entity extractions. So we need to create a typical JSON template so that it goes into the booking system. So for that, we need essentially the SLM's capability should be able to give out a perfect JSON file. In that way, there were challenges in terms of we tried different model combinations out there in the market, but probably we cannot go for a Claude, etc., because it's not proprietary. It's a proprietary model. So we tried with all the open source model available. That's one of the reasons we went to the AWS side. So I will come to that journey. But the problem was that there are slightly misalignments in terms of getting the error out. Essentially, a token mismatch error is there. It's slightly difficult to get around it. The reason again, the AWS Distillation services help this because a lot of these errors are handled by default in their framework. That I will come to. But you can do it using a PyTorch custom framework. It's possible. You do need to have a in-depth understanding of the engineering framework of that and the architectural part of the teacher and student mode as well. That is one approach. The second is a feature based, as I told you. Here, the architectural matching between the large language model or the teacher and student is extremely critical. The most, I would say, the most similarity what we found from my experience is Nova Lite and Nova Pro. Even Llama models had a not so quite so similarity in terms of that architecture similarity, because we are talking about attention mapping here. It is extremely difficult. So we tried with the text explorer as well, but it could be done. The point I'm trying to say is it's not impossible. It is slightly difficult. There is a lot of engineering effort into it. So IBS as a company, from a business point of view, if you look into it, we are looking at outputs, solving the business problem. That's why AWS Distillation as a service comes into picture. So all these are possible. All these we have tried maybe, and from a company who has a much more larger bandwidth in terms of engineering capabilities and slightly different goal from a research perspective, can go in deep into that. But we took a pause. The reason that's where I'm coming to. So the problem was that it was not the problem with the framework audit. It was we wanted an output as quick as possible. It makes sense from a business perspective, and we wanted to solve it as simple as possible using a service. Because typically, if you look into it from a distillation perspective, there are multiple steps involved in terms of a simple example is, for example, the input file, right? I have told, as Joshwin was mentioning, in the email comes in a very textual format. You cannot field that text in as such into a distillation service. You have to convert that into a JSON-L file. Probably, I hope everybody knows JSON-L file is, right? So you have to. So now the challenge is the incoming text is both English and Japanese. You cannot convert straight away English and Japanese text into a JSON-L file because of the Unicode problems that props up in between. So you have to handle that as well. So what I'm trying to say is, when you build a custom framework and try to do all these things, every nuance of preparation through the process is a challenge. So that's the reason when you use some services like AWS Distillation services, most of the nuances are taken care. That is one thing. The second part of the problem is, if you look at here, when you do the processing part, there is say for example, again, if you think about Llama is an open source model, right? Llama also has a small language model. We typically think of it like, take the small language model, tune it so that we can have a SLM model, because it's an open source model. We can have our own IP. That's perfectly correct. But the problem is that now if you go back to the methods I have talked about, you need to run the teacher and student almost in a parallel way. So you need the compute environment for that. There's a cost involved for that. And given the engineering problem and the framework problem, it is a costly method for us to do that. So when AWS provides something, as a service, a lot of computational underlying managing infrastructure, the scaling part, etc., are taken care of. So that is another nuances. So the reason I have put the person in this way is because just to understand that you cannot just put a random text onto the framework and do it. There are obviously framework selection required, data preparation is required. You need to probably normalize data as well in some way, depending on your business problem. And in our case, it was more of bilingual because we had to support both English and Japanese. That was another challenge we had. So those kind of nuances also need to handle. So that is essentially, I think we tried all these using custom framework PyTorch for some time, and then we took a decision at some point in time. We took a pause and took a decision of going with AWS and trying out AWS. The reason because we are not going. Our focus was not on cracking the Explorer PyTorch engineering problem. Our problem was to create an SLM. So the focus we shifted. That the reason we pivoted to that way. Yeah, I think the rest of the thing Joshwin will talk about it.
Yeah. So as Manu mentioned, so why we failed during the first and second attempts, and what was the real problem that we have? So it was not a kind of ML problem, but what we faced was a kind of engineering problem, due to which we were unable to have a kind of specialized SLM for this purpose. So there are different aspects which are coming into picture here. So one of the main thing is like different models have different kind of architectures. So while we are trying to distill a model, the entire architecture should be same of the student and teacher models. Otherwise, there can be a failure in between, and we will not be getting the proper outputs after the distillation. So that is one of the main thing, and also there are kind of data issues, structure issues within the data, Unicode encoding, etc., which also caused some kind of disadvantages for the distillation. So at last, we had done our research where we come into the AWS side. Previous to this, we have done distillation on top of Llama models and some QN models, but finally we come to the AWS Nova models, Nova family, where we have the Pro as a teacher model and the Lite, which will be serving as a student model. So actually, these two serve the entire similar architecture, and also some of the things will be handled in the backend. I mean, the engineering part will be handled by the AWS in the backend, which help us in order to easily achieve the required output in a lower cost. So the entire things that we done during the process is like there are some prerequisites. So first we should prepare the data in a way that the particular model will accept it for the distillation purpose. So different models have different requirements. For the Nova models, currently it is kind of JSON or JSONL data, which will be or can be fed into the model in order to take the output. So while preparing this, we should have a kind of structure where we should first, in each JSONL, it should have the input, the prompt, and also some kind of expected output, can be a format, etc. So that is the prompt data set, and in a kind of JSON file, which will be dropped into the S3 bucket, the object storage in AWS. And from there, we could trigger a API for the distillation job, where we could provide the model details like the teacher model, the student model, how much epochs this should run, etc., which will be done by user. And we will be triggering the distillation process. So once the distillation process is started, it will take around some time, like few hours, in order to complete the entire distillation process according to the data set size. So once this is done, we will be getting a model in the S3, but which cannot be taken outside of S3, but we can host directly in Bedrock itself. So here we have a greater advantage compared to the normal models which we distill, because if you are planning to distill a normal model, we cannot host it in a kind of serverless or on-demand mode, because we should provision a GPU servers for that, and we should host it, which will cost pretty much high. But here, AWS has a dedicated service, like we could host it in a serverless manner for the custom models, and we could do the inference on top of that, which will be charged on the basis of token size. Okay, so as I mentioned, why this succeeded, I have already mentioned the steps, because we have a kind of engineering problem, not a data science problem. So we focused entirely on the data science rather than the engineering, where AWS handled the engineering part with the help of Bedrock and the backend servers. Yeah. So this is the statistics of the model which we have distilled. So we ran around 4 epochs, and the total steps were 70. And this is the metrics that we received from the Bedrock distillation process. The loss was, at the start, it was around 0.05, and it comes around 0.008 at the end of the 4 epochs. Yeah, so this is the overall statistics which we shared across after the comparison with the teacher model and with respect to the student model. So in the Nova Pro, we received around 97% of accuracy, and in the Nova Lite model, we have somewhat near like 95%. And since it is bilingual, for English and Japanese, it is different. We have used somewhere around 500 data sets for the English and 150 for the Japanese. So still we are trying to enhance the Japanese data sets in order to increase the accuracy. So for English, it was somewhere 96.5, which was something above than the teacher model. And for Japanese, it is 93. So comparing the cost, as I mentioned, for invocations, as per the token cost, for Nova Pros, we have a higher token size costing for 1,000 tokens. But for the Nova Lite models, we have a 14 times reduced cost. Yeah, which is a kind of uh, advantage for us. Yeah. Yeah, so this is the common entire structure for the distillation process where we can give our prompt, which will be fed to the teacher model, and teacher model will be generating the response based on the input, prompt, and the data. And we will be creating that as a synthetic data, which will be fed to the student model and will be used for the knowledge transfer purpose from the teacher to the student. And once the distill model is being hosted, we could do inference on top of the distill model. Yeah, so as I mentioned, this will be the kind of structured input where we will be providing the prompt with the input data, and that will be the expected output in our case, but it differs in each case. Yeah, maybe we'll move on to the takeaway part 2.
Yeah. So the crux of the message, what we are trying to convey is that, as you may have noticed, the student model actually was performing in certain areas much better. That is one point. It's called a distillation blessing. Maybe I don't know whether you know the terminology, but that's what we got for the especially for the English proficiency. Japanese, we got almost equal proficiency as well. So there are two things Joshwin has mentioned, right? If you look it from a capability perspective, we are getting Nova Pro's capability in a Nova Lite at almost like 1/14 cost. That's point number one. And given the AWS right now, if you look into it, they have given a capability of hosting is on demand. So that means even if this is an SLM, you don't need to have a throughput maintained all the time. It is on demand. So your cost is reduced in two ways. If you look at from a token by token level as well as it's an on-demand basis. So that's a two-way we are reducing the cost. Plus we are bringing almost similar, in some cases better capability from an extraction perspective onto an SLM and hosting it as well. And if you look at from a latency perspective, it is almost as performance is almost as similar at a large language model. So almost for the same performance, we are giving 1/10 cost can be achieved, and plus giving the serverless capability of hosting in the AWS. That is a win-win situation for both of us. The only disadvantage with it is that we cannot take it from the AWS ecosystem. That's the only flip side to it. So for that was the reason we tried for the custom framework and Explorer, etc. Because we cannot take, if you want to take an SLM out or put it into any AWS or any other cloud environment, currently it is not possible. Maybe AWS will come out sometime later. But currently what happens is if you use the AWS Bedrock service, it resides somewhere in S3, and that S3 bucket will not be able to take it out from that SLM. As we speak, it may change, but that's how it is. But we can tie that as a source system for on-demand and use it on inference on demand. So that's how. So the point is the cost is on these fronts. Similar capability, 1/10 cost on a per token basis. On demand, as because there's a custom LLM, you can embed it in your products and your workflows as you require. And thirdly, the latency and the response times are almost similar to a Nova Pro, if not better, because of the smaller language model as well. So that's how it is. So that's what we are trying to summarize here. And just a quick point, Joshwin mentioned that as well. You typically can do NERs, etc., in BERT, etc., the advanced model BERT, etc. The reason we went for LLM is for the bilingual capability that we wanted Indian Japanese to be the same LLM to understand. And second is from a, if you look at from a context perspective, the input comes in threads. In one email, customer says one thing. Maybe in the 13th email, his customer says the 13th thing. So we want at least 23 plus entities be mandatory to complete a booking. So that 23 may come in 30 different emails. So using BERT and other custom models, it could be possible, but slightly more easy. From a tool level perspective, if we look at it from engineering perspective, from a business perspective, that is how we can tackle it. That's the reason we went with the SLM journey as well.
Yeah.
Okay.
So basically, we have a kind of more accurate, less cost model, which will not bankrupt. Yeah.
That's what. So ROI. Yeah. So that's it.